You excited to figure out how to check for assumptions in Jamovi? I know you are. So enough chat, let's get to it. So once again, we have Jamovi open, and I'm going to go ahead and jump right into it and go to the hamburger menu there. That's what that thing's called, by the way, hamburger menu. And I'm just gonna open up my exercise data set, which is the same data set we loaded before. And it looks like, once again, it is treating weight loss as if it is numeric. So I'm gonna go under data, and then under setup, and then change it from a nominal to a continuous variable. And then now I'm ready to do my analysis. And just as before, I'm gonna click on Glen mod, but rather than going to FlexPlot, I'm gonna choose General Linear Model. The General Linear Model is the model that most all statistics use. It's basically just algebra plus error. You remember how I said in the last video that in order to assess the assumptions, we actually have to make a model. And so that's what we're gonna do right now, but what we're going to specifically do is we're going to unclick Report Estimates and Effect Sizes. And why is that? Because we do not know if the model is trustworthy yet, but we're going to leave on visualizing the analysis, plotting diagnostics, etc. So let's go ahead and look at weight loss again here, and then therapy type as a predictor variable, and then give it a minute and it will show you the diagnostic plots. And so we have our residual diagnostic plots here. The first one is the normality assumption. So this is just plotting a histogram of the residuals. And although there is some noisiness, some asymmetry here, it looks approximately normal, nothing to worry about, some outliers, but nothing extreme and nothing too egregious going on here. So here's our SL plot. Now remember, the x-axis tells you what the fitted values are. So this, we have a bunch of, 7.8s going on here that have been jittered. And so that is the fit for, let's see, which group would it be? The behaviorist group. Because notice the behaviorists, their median here or their mean or whatever is about 7.8. So that tells you the fit of that group is right there. That is the behaviorist group, which makes this the cognitive group. And notice that the absolute value of the residuals or the amount of spread does not seem to change, which is good. So there's about the same amount of spread or uncertainty or variance in both groups. So the homoskedasticity assumption holds. And then now we will go down to the analysis plot and look at the behaviorist condition and the cognitive condition. And we've seen this plot before. Not gonna spend a lot of time reinterpreting it. Of course, we can, instead of median and quartiles, we could do mean and standard deviation, for example. And that will redo the graphic and etc., etc. So what we've learned from this data set is behaviorists are higher than the cognitive group. Normality assumption is approximately met. There's some bumpiness going there, but nothing to worry about. And we are basically meeting the assumption of homoskedasticity. But I bet you want to see a data set where all that is problematic, don't you? With that, we're going to open up the NSDUH data set in the description. And long story short, NSDUH is the National Survey of Drug Use and Health dataset, federally funded. It's got 41,000 observations on a boatload of variables, but the dataset that I am giving you has only 1,000 observations on something like 10 or 20 variables. And I'm doing that just because with large data sets like that, it's more likely your computer's gonna crash and things are gonna take a long time and you're gonna get frustrated. And hey, statistics is fun. I don't want you to get frustrated. So with that, we are going to go into our hamburger menu and then open, and then you will navigate to wherever your file is. And the file name is NSDUH_small, so we're gonna go ahead and open that sucker. And we have a bunch of variables. We have recency of cigarette, alcohol, cocaine, and heroin, with people answering never or more than 12 months, but less than 3 years. And then we also have alcohol frequency, how frequently to use alcohol, and a bunch of other variables. But the variables that we are interested in is Hudas impairment. And again, it is treating it as if it is nominal. So I'm gonna go under data and then set up. And I'm going to say that this is continuous. And then the other variable that we are going to be interested in that's going to need some work is this health rating variable. And looking at this, you know that there is some natural ordering to it. So we've got excellent health, very good health, fair, good, poor. But it is treating it as a nominal. And remember that a nominal, there is no inherent order. And we don't want that. We want it to know that there is an inherent order going on here. So we're gonna change this to an ordinal variable. And then what we have to do is we have to modify the levels. So we're gonna put very good up to indicate to the computer that excellent is higher than very good, and then good is lower than very good, and then fair, and then poor. So this is in the correct order. It's very important to get that done so that when we actually look at the visuals and run the analysis and that sort of thing, it's going to make sense. So now we are ready to go under the GlinMod tab, and just as before, there is a GlinMod and then a flex plot. We're gonna go under GlinMod, or General Linear Model, and then under the outcome, again, I'm gonna uncheck Report Estimates and Effect Sizes. Under the outcome, I am going to put impairment on the outcome variable, and then health rating on the predictor variable. And this is going to give me my residuals first in, uh-oh, we have problems. So we've got a very, very asymmetric distribution. It's severely positively skewed. And so we know we've got, the residuals aren't normally distributed. And then now we have the SL plot. And again, SL stands for spread location. And what we see is that that line ain't flat. So for those who have a higher value of impairment, we are more uncertain on average. And those who have lower values of, oh, did I say impairment? I meant to say those who have, oh yeah, predicted values, that's right. So those who have low predicted values of impairment, on average, we are slightly more certain. And then here is our actual analysis graph, and we see that those in the poor condition have the most impairment, and then gradually it goes down to those who are excellent. So this is the pattern that we would expect, but obviously the model that we are running is ill-equipped to handle this sort of data analysis. Unfortunately, we're not going to cover how to address these problems in this class, but if you are dying to know, go ahead and see the link in the description to my generalized linear model video. For this one, we have violated the assumption of normality and homoscedasticity. The linearity assumption doesn't apply because we have a categorical predictor. Now let's go ahead and see what happens when we have a continuous predictor. So I'm gonna go up to MI, which stands for mental illness. And that's going to allow me to assess the linearity assumption. So not surprisingly, the histogram of my residuals is cray-cray. That is just bad. Really, really bad. So the residuals are very clearly not normally distributed. And then our residual dependence plot, as you will recall, what a residual dependence plot does is it takes out the straight line and shows you what remains. And so what we see is there is still a whole lot of information left in the data that we haven't modeled. And so it would be a bad idea for us to assume a straight line when clearly a straight line isn't gonna work. And then finally we have the SL plot, and again, we would like to see flat lines, and we do not see that here. So those who have higher fitted values of impairment, we are less certain about their score than those who have low fitted values. And then here is our analysis plot. Not surprisingly, that just looks wonky, wonky, wonky. Clearly a straight line is not appropriate here, but we do see an overall trend that as you increase in mental illness, impairment also increases. And let's go ahead and take a second to think about what this is actually saying to us. It tells us that at the very beginning, as you make small increases in mental illness probabilities, very rapidly your impairment goes up. And then it kind of sort of levels off. It doesn't level off, but the increases in impairment are much smaller per increase in probability of mental illness. So that's actually kind of interesting. So basically that says, if you want to not be impaired, have 0 probability of mental illness. And very tiny increases in the probability of mental illness means massive impairment. So that is just a very, very brief introduction to looking at diagnostic plots in Jamovi. Hopefully you feel comfortable doing that for your own data analyses, and we'll see you next time.